Okay, so we're going to go through a few more examples and then I'll come back to the multiple choice I was talking about when I got cut off on the last video. So this next example here is a word problem involving bearings. These diagrams are not easy to draw. You've got to take them slowly and practice them. So it says to avoid a swamp, Jane runs 70 metres on a bearing of 50 degrees to V. So we'll do that bit first. Put the bearing on first. Go from north clockwise through 70 degrees. And that's the direction that we're heading. And we're running for 70 metres. Okay, now she goes to V. So we'll put a V there. Then she turns and runs to W on a bearing of 120 degrees. Now remember, we're now here. So we need a new compass drawn up for where we are now. Okay, so now we're going to go on our bearing of 120 degrees. So go from clockwise from north through 120, we'll end up going down that direction. I might just move that V out of the way so we can see it. Sometimes you need to redraw these. So that's the V there. All right, if we go 120 degrees on our bearing, that's that angle there. And we go off on that bearing to W. And it says that W is directly east of U. At some point they should have told us we were starting at U, so we'll put it over there. So we're going to keep going to we're directly east of U, which means we go and stop on the east line. All right, so we're going to W here. W is directly east of U. All right, so that's our diagram. So now we're going to try and start finding these questions. Part 1, find angle UVW. So we've been asked for UVW, which is this big angle here. That's what we've been asked for. So let's see how we can find that. What information have we got here that we can help us find what we're doing? Well, we know from here to here is 120. So if we continue to the south line, this little piece here will be 180, take away that 120. So if we do that, we're going to get 60 degrees in this section here. Now the other section on the other side, this bit, from here to here, that bit, if you look over here, you'll see that you've got a Z shape forming. That means we have alternate angles if we look at our parallel lines, our two north-south lines. So if that's 70, this is 70 due to alternate angles. So all of this actually is working. So if you draw your diagram nice and big and clearly, just put that up a little bit, then that's part of your working. The teacher marking it will be looking at it all to see what you've been doing. So to find angle UVW, we need to add these two pieces together to get this whole angle. So we've got 70 degrees plus this 60 degrees. So that angle there is 130 degrees. Now in a test situation, if you get stuck on that bit, you can't find it, make something up. Just go, angle UVW is, 98 degrees. Make something up, okay? Because you're going to need that to continue on with the next part of the question. When they number things in an exam with Roman numerals like this, with the I and the double I, it means that you need to use part 1 in part 2 to get the answer. So if you're stuck on part 1, make an answer up so you can continue on part 2 and not lose any marks on part 2. Okay, so let's have a look at part 2 now. We're calculating UW. Now, have I left any measurements off here? No, I don't think I have. Okay, so I'm going to just draw the triangle that we're looking at. This is the triangle we're looking at. It's just easier than looking at the mess that we have up there now. So we have 70 metres there. We've just found that to be 130 degrees. And what else do we have? One side, one angle in the middle here. And they're asking us for, I'll just put these letters on, we've got U, V and W. They're asking us for UW, so we're looking for this side here. All right, now we are missing a bit of information here because we're looking for a side and we know that we're going to be using this formula to find our side. And if you think about it, we need three things to do that. We need something here, here and here. So there's three things we need. I can only see two. 1, 2. So we've got to try and work out what's missing here. So if we're going to find that side, we're going to call that side A for our formula. That makes that up there, angle A. And what have we got for our B's? Well, we've got side little b here, but we're missing the angle B opposite little b. So we need to know what this angle is here. So we've got to try and find that now. All right, let's see if we can come up here and try and work out what that angle is there, this one. How can we find that? Well, there's a few different ways that you can find it. It doesn't matter how you get there as long as you get there. But what we can do, we know that we've got 130 up here. What would this angle here be? That angle there. That's right, a right angle there. So if you've got 70 here, this is going to have to be 20 degrees because we're doing 90 take away 70 and we'll get 20 degrees for that angle. So if I put that in, then I can do, we know that there's 180 degrees in a triangle. So if we do 180 take away 130 take away 20, that will leave us with 30 degrees. So now we do have angle B and we can proceed with the question. This angle here, we don't need it. I'm going to cross it out. It was there to help us get this, but that's the one we're using. Okay, so let's start subbing in now. So we'll call it little a. Little a over sine of the opposite angle, which is 130 degrees, equals the side length that we have, 70. So that's the only side length. We have to use that, and we've got to use the angle opposite that. So it's sine 30 degrees. Okay, we know what to do now. We're going to get rid of our divided by sine 130. Come over to the other side and write 70 over sine 30. Now do the opposite of that, so we're timesing by sine 130. Be careful with the 30s and the 130s, you don't get it all mixed up. Then we're going to our calculator and we're going to put this in the calculator. Okay, so we have fraction key, 70 on the top, down arrow, sine 30 on the bottom, close the bracket, right arrow out of the fraction, times sine 130, close the bracket, equals, and this is what we get. Okay, and now we are rounding to one decimal place like they've asked. And that 2 is going to stay because we're less than 5 here. And then you've got to put your units on the end. It's meters for that side length. Okay, so it's always a good idea just to check at the end whether your answer makes sense. So if we have 70 metres opposite this 30 degree angle, once you've got a bigger angle, you would expect the side opposite to be bigger. Okay, so it needs to be bigger than 70. It is. Okay, so it's a good check. All right, we're doing another question here. This one's harder again. It involves speeds, and it's always a little bit trickier when we've got speeds. Okay, so we have two planes leaving the airport at the same time. So we start off with our compass and our airport. Airport 1, because we're considering another airport in a minute. Airport 1 is in the middle of the compass. So the first plane flies due south at 400 kilometres per hour and lands at a second airport after 1.5 hours. So here's the first plane. All right, and it goes down and it finishes there at airport 2. All right, now we don't know a distance there yet, so we've got to use our distance, speed, time triangle. We are looking for a distance, so we're doing distance equals speed times time. So looking at the first plane, it's 400 kilometres per hour, and it travels for 1.5 hours. So we're going to work that out on the calculator, and you'll get 600 kilometres. And that's the distance for the first plane, so let's write it on. Okay, next part. we're looking at the other plane. The other plane flies on a bearing of 130 degrees from that same airport. So if we put in our 130 degree bearing from north going clockwise, we'll end up going down here. This is 130 degrees. Okay, so it flies off on the bearing of 130 degrees, and after 1.5 hours, it finishes at a bearing of 75 degrees from the second airport. So if you think about it, I am going to cut this line a little bit short and finish it there. You'll see why in a minute. So if we have a look at the second airport, and just draw our compass up around that, right? So it says from the second airport must be in the middle of the compass. And if we do the bearing of 75 degrees from there, then we go 75, off we go, and it's going to end up being where that is. Okay, so 75 degrees is in that angle there. All right, so the only thing that you could have really done wrong here is sometimes when people draw this up, they would have had their 600 here, they go flying off on their bearing of 130 degrees and they might do that. Okay, now at that point, that's when you're going to realise you're wrong, because once you start doing your bearing here, you go, okay, my second plane is here, and this is the second airport, and I go, okay, we're going from north, let's draw up this compass, through 75 degrees to get to here. That doesn't look right, does it? That is definitely not 75 degrees. So you've drawn your line too long. The plane didn't go that far. The second plane must have been more like here, and that looks like 75 degrees. So this is where you can get your diagrams a bit wrong, but we all learn from mistakes we've made and from experience. Just redraw it. I've had to draw some of my diagrams 3 or 4 times to get them right and just to be able to see what I've drawn on them, particularly when you get to year 11 and 12. So just redraw it. We make mistakes, we don't interpret things right sometimes. All right, so we're going to go from here now. So what we've got in this question now, they're asking for how far is the slower plane from the second airport. So remember, the first plane's already got to the second airport. This is the slower plane because it's still in the air. So we want to know how far that is from the second airport. So we're looking for that line there, the red one. All right, so looking at our triangle, let's just draw up what we've got as a triangle without all the compass directions on it and see what we have. Right, so we have airport 1. Here's our slow plane, still in the air. And here's airport 2. And we know that we're looking for how far that slow plane is, or distance it is from the second airport. Okay, so let's see what we know. We've already got a distance here of 600, so we need to use that side length. It's the only side length we've got. So it's the angles that are a bit of a problem trying to work out what they are. So what angles have we got inside this triangle? Let's see what we actually know. Well, I think if you come back up here to this bearing diagram that we've drawn, I think you should be able to see what that angle is. If you've got 130 to there, what's that bit? It's going to be 180 minus 130, so that's going to be 50 degrees. So I'm going to mark that in on my triangle down here now. So I do have an angle, okay, and it's good because I've got the angle opposite the side I'm looking for, so that's a good sign. I do need that. The other angle I'm going to need is the angle opposite this side. So I'm going to need this one. So I've got to try and work out how I'm going to get that angle up there. How can I work that out? All right, so let's just see what we do have. If we look at these east-west lines, they're all parallel to each other. Okay, so if I split it, wish I had another coloured pen, but I'm running out of colours. I'll just continue to use the red one. If I split it down the middle here like that, and create another parallel line with the east-west line, so they're all horizontal. Let's see if I can find the bits I need. So this bit up here, from here to here, that's 130 there. From here to here is 90. So this bit here would be 40 degrees. Okay, because it's going to be 130 take away 90 for that. So that means I'm going to have this bit here going to be 40 degrees as well because of alternate angles. Can we see the Z shape there? All right, so I know that that little bit, if I do it in there, is 40 degrees. Okay, so what else do we know? What about this bit down here? Can I find that? All right, well, let's see. We know that this angle here is 75. All right, so if I just draw a little diagram here for this bit, that's 75 degrees. That's going to be a right angle. This bit here, we 90 take away 75, 15 degrees. So I know that that bit is going to be 15 degrees. Let's write it in here. So now I know that whole angle there is 55 degrees when I add it all up. So it's pretty tricky. That's why I'm going to go through this question with you on the board. All right, so from there, we're going to start using our formula now. A over sine A equals B over sine B. All right, we're finding this red side here. I'm going to call it little a. That means the opposite angle is angle A. Our other side is little b, and the angle opposite is angle B. Okay, let's put it all in. We have A over sine 50 degrees equals B over sine 55 degrees. All right, so now we're getting the A by itself. This doesn't move, but we're doing the opposite of divided by sine 50. Come to the other side, times by sine 50. Okay, so we're just going to work that out on our calculator. See what we end up with. So pressing it in your calculator, fraction key. On the top we have 600, down arrow, sine 55 degrees. Close the bracket, right arrow out of it, times sine 50. Close the bracket off, equals, and here's our answer. Right, we're going to the nearest kilometre if you read the question down there. So that's the nearest whole number. This is in kilometres because the other number, side length, was in kilometres. So we're just going to the nearest whole number. 561 it will be, kilometres. So there was a lot in that question and it is tricky. All I can suggest is if you get something this hard in a test, do everything you can to show what you're doing. All right, if you get stuck on a part, guess that section and keep moving on with the working. Now I just want to come back quickly over to this bit I was talking about at the end of the video before. Sometimes on a question like this, I'll give you multiple choice and say which one's right. Let's just forget option D here. Now, if you look at this line here, we can slide that together. Okay, so if we slide that together, it will look like 50 sine 59 degrees on the top and sine 33 degrees on the bottom. Okay, so that's all they've done. That's why I deliberately write that above on the top, lined up with the top of the fraction. Okay, so then you can just push it together so it looks like that, and the answer would be that one. Okay, they just might do that on a multiple choice question sometimes. Okay, so this obviously needs a lot of practice. The work next lesson, we're doing the sine rule for angles. Then we move on to the cosine rule. You must practice each section, otherwise it's going to end up just consuming you. All right, so practice, practice, practice so that we can move on to angles next lesson.